in this session, we're going to work on the Chapter 3 review. So let's start with the first set of 4 problems. We're dealing with this picture up here to the right, and it says, think of each segment in the figure as part of a line. Which lines or planes appear to fit the description? The first problem says lines perpendicular to line QR. Well, here's line QR, and we can clearly see the right angle symbols here. So the lines that are clearly perpendicular to QR would be, this is for number 1, is line PQ and line NR. Okay, now here we have a line going vertical, 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 and vertical, but it doesn't look like there are right angle symbols here. I'm going to assume, for the sake of discussion, that that's an omission on the part of the author, because it would appear that this is intended to be a rectangular prism. So we're just going to say, for the sake of discussion, that this and this side are perpendicular. And in fact, according to the author's answers, yes, MR and LQ are perpendicular to line RQ. So we have line MR and line LQ. Now, strictly speaking, if this were shown on a test or some other such thing, because there's no right angle here and because the description doesn't say that these are perpendicular, you would normally say that this is not perpendicular to that. But as I said, it's an omission on the part of the author, so we're going to assume it is. Okay, problem number 2. Now, as we move forward with the rest of these problems, because this is a review, a chapter review, we're going to assume, in fact, all of the postulates and theorems from the chapter from the beginning. If we were looking at this from a section 1 standpoint, we wouldn't know some of the things that we're going to use in evidence. But because we've finished the chapter, and this is a chapter review, we're going to assume that we know these things. And so we're going to use all of the tools at our disposal to make these determinations. So that's the standpoint I want to go by from this point forward. So for number 2, it says lines parallel to QR. Well, here you have 2 lines. We're going to consider NR a transversal. And we have 2 right angles here. These 2 angles are consecutive interior angles, and they're both congruent because they're both right angles. Therefore, we know that this line is parallel to this. And we're going to consider that this is, in fact, a right prism, which means that every one of these sides, every one of these edges is perpendicular to the base. So we're also going to say that JK and line LM are parallel for the exact same reasons. Since this angle and this angle are right angles, this and this are right angles. So for number 2, we're going to say lines parallel to QR. We have line NP. We have line JK, and line ML. Okay, so continuing on to problem 3. Lines skew to QR. Skew lines, as you recall, are lines that are not coplanar and do not intersect, but are not parallel. So if we have QR here, lines that do not intersect but are not parallel would be JN, this line here, KP, those are two going in the same direction. So for 3, we have JN, KP. So those two are going in the same direction. We also have line JM, which is going in this direction, and KL, which is going in the same direction. So again, to QR, in this line here, we have JN, KP, JM, KL. So JM and line KL. Okay, now to problem 4. Planes parallel to plane LMQ. So here's plane LMQ. It's this face on this side. So we know that this plane is going to be parallel to this back plane back here. So that would be, we could name that pretty much anything we wanted. Remember that we name planes by any 3 non-collinear points. So we have plane, now we're going to use J and P for the sake of discussion. J and P. We could have said JKP, we could have said PNJ, we could have said JPN. Any 3 non-collinear points names that plane. So now we're going to move on to problem 5. Okay, for problem 5, we have up here 2 parallel lines. These marks on these 2 lines indicate that these 2 lines are parallel. So we have 2 parallel lines cut by a transversal. And here we have this angle and this angle. They have a special relationship here. We know that when we have a straight segment and another segment intersecting, this angle and this angle are known as a linear pair. Anything that shows that relationship is a linear pair. Linear pairs are supplementary. That is, this angle plus this angle add up to 180 degrees. So here we have 2 angles that form a linear pair. Therefore, they are supplementary. So this angle plus this angle equals 180 degrees. And so for number 5, we have x plus 35 equals 180. We're going to use the subtraction property of equality to subtract 35 from both sides, and x equals 145. Now, for angle y, we can see that this angle and this angle are corresponding angles. That means that this angle and this angle are congruent. If 2 parallel lines are cut by a transversal, then the corresponding angles are congruent. So the other part of 5 is y equals 35 degrees. That's supposed to be degrees there too, but okay. Now let's move on to problem 6. In problem 6, we have if we want to find the measure of angle x, we have x in this angle and 48 in this angle. Again, these two lines are parallel, given by these two marks. These two angles are alternate interior angles. So, if two parallel lines are cut by a transversal, the alternate interior angles are congruent. That means, for problem 6 then, we have 5x minus 17 equals, since they're congruent, the definition of congruent angles means their measures are equal. So 5x minus 17 equals 48. So now we use the addition property of equality to add 17 to both sides. So 5x equals 65. Then we use the division property of equality to divide both sides by 5. X equals 13. So that gives us the value of x. Here we have a different relationship between 48 and angle y. These two are consecutive interior angles. If two parallel lines are cut by a transversal, then the consecutive interior angles are supplementary, which means this angle plus this angle add up to, I should say, 180 degrees. So 48 plus y equals 180. Now we will use the subtraction property of equality to subtract 48 from both sides, and y equals 132. That takes care of problem 6. Now we move to problem 7. In problem 7, we have another different situation. Here we have two angles that are also a linear pair, therefore they're supplementary, so their measures add up to 180 degrees. So in problem 7, we have 2x plus 58 equals 180. We're going to use the subtraction property of equality to subtract 58 from both sides. 2x equals 122. And then we're going to use the division property of equality to divide by 2. X equals 61. Now, since x is 61, we could either use this angle and this angle, or we can just use the standard corresponding angle pair here. So let's go ahead and use the corresponding angle pair because that's the most straightforward. Again, if two parallel lines are cut by a transversal, corresponding angles are congruent, which makes this angle and this angle equal. 2y equals 58. And we use the division property of equality to divide both sides by 2. Y equals 29. That takes care of problem 7. Now on to problem 8.